Now we're gonna see the fundamentals of fuzzy logic. There are four important pillars in fuzzy logic systems. The first of them would be the fuzzy sets. What is a fuzzy set? To better understand the fuzzy set, we're gonna compare it to a crisp set, which we already know and we are used to this set. In classical crisp set, elements either belong to a set or they don't. This binary approach, either 1 or 0, this binary approach fails to account for gradual transition. Fuzzy sets, however, allow for degrees of membership. This is where the degrees of membership comes in place, which means moving out of a set, it's not directly a 0. For example, a basic example of height measurements. We have some algorithm that can tell us either someone is tall, medium, or short. You give it as an input your height, and it gives you as an output your height classification. Either you're tall or medium in size, in length, or in height, or you are short. In a crisp set system or algorithm, you would be, for example, in the code, the source code of this system, you're gonna see that there are some conditions. If the input height is greater than 180 centimeters, then this person is tall. If it's below that, then this person is medium, is in medium height. You see already that the problem with this crisp set, you are moving directly, discontinuously. There is no gradual transition from the medium to the high or to the tall height. Someone with 178 or 79 centimeters will be classified as a medium, but one with 180, which is 1 centimeter above, would be classified as tall, which doesn't make sense. So this is where the fuzzy sets comes in place. That tells you that you don't have to be 100% into a set or 0%. You could be anywhere in between. Like you see here in this figure, you have y or x doesn't belong to the A set, neither the B. The y belongs totally in the A set, which is 1, and x, which is a 0. But z, it's also totally in B, but t, as you can see it's in the fuzzy region. And this fuzzy region, it's neither a 1 nor a 0. It's partially. It's included in B partially, which is very good for like human-like situations and algorithms. Membership functions. Now we can see that each of this set are going to be transformed or can be modeled into a function, which is the membership functions. A membership function defines how each element in a fuzzy set is assigned a degree of membership between 0 and 1. It's the function that tells you where are you in this set. Are you 100% in it? Are you 60% in it? Are you 40% in it? Are you 0% in it? It mathematically represents the transition between belonging and not belonging to a set, the transition, which is all the values between 0 and 1. Common types of membership functions include triangular, trapezoidal, Gaussian, sigmoid functions. There are a lot of types. There isn't just these types. A lot of types that can model our fuzzy or our membership function. In the figure in the left, you can see that the very basic example of a credit card. Is a credit card good, classified as good, or neutral, or bad? In a crisp set or in a binary system, with the conditions that tells that if the credit is greater than 750, then the credit is good. If it's below that, then it's neutral. You can see the problem, like we said with the height. A credit of 750 is classified as good, but 749 is neutral. It directly comes out of the set because it's crisp. There isn't in between. You're just jumping from state to state, which is very like it doesn't portray the truth 100%. There is a lot of missing information, and it's not good for decision making, since you're gonna base your decision out of a bad or an, not like 100% true model. But as you can see in your right, there are the fuzzy logic approach, which tells that we take, for example, a set of experts in the field. For example, here the credit cards and the we're gonna take bankers. The example says that we take 100%, 100 bankers, and we tell them what is for you, for you as an expert, of course, not for you subjectively, 100% subjective. It is subjective, but you are talking with experts, those who are in the field and know what a good credit card is, and what is a neutral one, and what is a bad one. So you tell them, what do you think that, for example, 300, the credit of 300 is good? All of them, all of the 100 bankers will say no, it's a bad credit. And you keep moving from one credit to another until you see you can like model the function that that is the set of this membership, the membership function that tells you where you are between 0 and 1. In the good, for example, the good membership is one set, the neutral membership is another one, and the bad membership, there are three sets here, as you can see in this example, in this given example. So a credit card, for example, here in of 700 is not 100% good, and it's not 100% neutral. It's 50-50, 50% good and 50% neutral, due to the transition and the gradual concepts in the fuzzy logic sets, which is portrayed here in the membership functions. The third fundamental of this fuzzy logic concept is linguistic variables. And we're going to see the concept of fuzzification, not now in detail, later. But now let's stick with what is a linguistic variable. The linguistic variable are the words used by humans that doesn't necessarily mean an exact number. When we see it's really hot here, we don't have a number in mind. You don't say, oh, hot. I can see that hot equals, for example, 30 degrees Celsius. It doesn't work like that. Our word doesn't work like that. So we're gonna take these variables, and we are trying to model them into a fuzzy variables. We take a crisp variable and we model them into a fuzzy variable. That's the fuzzification, but we're gonna see it in detail later. So the linguistic variable translates numerical data into human-like descriptive terms. Would describe something. For example, pretty hungry, it describes how hungry you are. Or hot, it describes the weather. Or, for example, the credit, a bad credit, it describes the goodness or the badness of this credit. Instead of defining temperature in strict numbers, fuzzy logic allows it to be categorized as cold, warm, or hot. Each of these terms corresponds to a fuzzy set with a defined membership function. Fuzzification. Now that's the linguistic variables. Now moving to the fuzzification, just to highlight it, a quick highlight. It's not the details of what does the fuzzification mean, but the fuzzification is the process of converting precise input values like 22%, 22 degrees Celsius into fuzzy linguistic. The fuzzification is the process of converting precise input values like temperature, 20% degrees Celsius, into fuzzy linguistic terms, partially warm, slightly hot, etc. That's the system. That's how the system processes the fuzzy variable. Since it's the fuzzy logic, so we are not dealing with crisp values. Now, as you can see down there, that's the steps or all the process of something which is called the fuzzy inference system. The fuzzy inference system, which is a system that takes as an input a crisp value and it gives you a crisp output. For example, you want to build a system that detects the weather in strict terms, like it knows with the sensor how hot it is, the temperature of the weather of this environment, this precise environment, and it outputs something which is crisp, which is the for example the speed of the fan or the air conditioner, its speed and its for example temperature that will be blown out of this air conditioner. These are crisp and precise values. In order to get there, we move through steps. We're gonna see them later, but these are the overview of the steps. The fourth and last fundamental of the fuzzy logic are the rules. There are the rules, the fuzzy rules in the inference system. They exist in a fuzzy system, fuzzy inference system. Fuzzy logic systems rely on if something, then something rules to make decisions. These fuzzy rules are structured as if condition, then result. The condition will be fuzzy and the result also will be fuzzy too. A fuzzy inference system, which is FIS, processes these rules to determine an outcome based on fuzzy inputs. The two main types of inference systems are Mamdani, which provides a graphical output using fuzzy logic, and Larson, the Larson system, which produces a precise mathematical output, making it more computational efficient. But we are going to stick to the Mamdani for this video. We can see other types in other videos, but we're going to stick to the Mamdani and the graphical representation of the fuzzy logic or the fuzzy inference system. This is, for example, a simplified risk assessment, which is the continuity or the continuity of the example given of the bankers and the credits. Now, once you did the fuzzification, which is taking a crisp input and making it to a fuzzy variables, this set of rules, these fuzzy rules, will take these fuzzy variables and output other fuzzy variables. But they are the decision, they are the output of our system. For example, if good credit, then low risk. If neutral credit, then medium risk. We are talking here about the bank system. If bad credit, then high risk. As you can see in yellow, the good, neutral, and bad, we already talked about these in the membership functions. They are fuzzy variables and they are ambiguous and imprecise and uncertain words. What do we mean by good? And what do we mean by neutral? We can't have an exact or a strict answer to this question, but we can have an overview of the membership function of each of these three sets. And the outcome is going to be fuzzy too, because we are not in the last step. We still have another step, which is the defuzzification that we're going to see later. So low and medium and high will be also portrayed in membership functions, in the mathematical model, or in a graph. But we're going to stick to the Mamdani, as we said, so we're going to just see the graphs. These rules are the encoding of knowledge that can be used for predictions. There are a lot of examples, as you can see, for the temperature and humidity. If the condition of the temperature, for example, is weak or is low, and or as we can see here, we used some operational or some binary operations with and or not. They are binary, but we're gonna use them. These basic operations, we're gonna use them in our fuzzy, as we're gonna see in the next part.
أخيرا وختاما أريد أن أبلغكم بشعار قناة روبوت إكس أند مور من أجل جيل هندسي مبدع. For a genius engineering generation. إلى هنا أقول لكم أعانكم الله.